Okay, so we're looking at homework from last night, number 19. I plug 3 in, direct substitution. 3 minus 3 gives me 0 in the denominator. That's a no. Okay, so I'm going to rationalize the numerator. Plus 2. And you got one like this in checkpoint. For some reason, these give students trouble. It's not that it's hard, it's that the math part of it. So let's watch this, yes.
So, on your third step, why do you not combine like terms? Like combine the x square root of x plus 1 and the negative 3.
Okay, because can I say x minus 3? That's why I keep combining. Now, if it was two numbers, I would exactly do what you said, but I can't combine the variable number. All right, so I'm going to multiply. This times this gives me x plus 1. The square root is gone. This times this is plus 2 square root of x plus 1. This times this is a negative 2 square root of x plus 1. Negative 2 times 2 is a negative 4. And I like that because these two monsters cancel out right there. Do you see that? Okay, now on bottom, the way this might get a little bit complicated, you've got to foil it. You just say x times this, x times that. Negative 3 times this, negative 3 times that. That's how I came up with this right here. And that is where students get lost. And let's make sure. Foiling. Like this times this times this. That's how I got these two terms. This times this is this. This times this is this. Okay, once I cancel these out, I'm going to try direct substitution again. If it doesn't work, then I got to try another strategy. So I'll take 3. 3 plus 1 is what? 4. Square root of 4. 2. 2 times 3 is 6. So I'm going to write 6 down to remember that. 2 times 3 is? 3 plus 1 is? Square root of 4 is? 2 times negative 3 is? So that cancels one of that pair out, don't it? And then I have another negative 6. So what do I still have on the denominator? 0. So I got to come up with something. Okay, I'm going to go to, there's no fraction, I'm going to go to trying to find a factor, okay? So I look here and I say, okay, I want to factor this. Well, these two monsters have that in common, don't they? So I'm going to put them together in the bottom and then put the 2x and negative 6 together. Do y'all see that? Therefore, I factor out the square root of x plus 1, and it leaves me x minus 3. So I got that. And I like that idea because what's about to happen? Cancel. I want to take a 2 out, and it leaves me x minus 3. So I rewrite it as x minus 3 and this plus this. Cancel that out. When I cancel that out, that's in the denominator. It stays in the denominator, but what do you put in the numerator? 1. Now I'm going to try direct substitution. I'm hoping to goodness I don't get 0 in the denominator. Plug 3 in. 3 plus 1 is? Square root of 4 is? 2 plus 2 is? Does that work? Yes. Yes. Square. It doesn't. That it's in the denominator because you're evaluating. You're going to get rid of it when you put that number in. Yes. 4th step. Right here. I factored it out. All right. Let's look at number 20. The limit as x approaches 1 of sine of pi over x 2. I'm going to do direct substitution. Plug 1 in for x. That gives me pi over 2. Well, do you know the sine of pi over 2? That's 1. There's your answer. That's just unit circle trig. 21. The limit as x approaches 0. I plug 0 in direct substitution. I get 0 in the denominator. Ding, ding, ding. Sirens are going off. I got to use a toolkit strategy. Well, there's no radicals. I'm not going to rationalize. There's no fractions. I'm not going to find a common denominator. What I'm going to do is try to factor something. Well, on the top, GCF, I can take an x out. Take an x out, that leaves an x minus 3. Cancel those x's, and I'm left with x minus 3. Well, now I'm going to apply direct substitution. 0 minus 3 is negative 3, and that's your answer. Number 22. The limit as theta, it can be a theta, it can be x, it can be anything. As theta approaches pi of theta times secant of theta. Direct substitution, I'm going to plug pi in for theta there and theta there. Okay, secant of theta. Not secant of theta, secant of pi. That's over here, isn't it? 180 is right here. What's my order pair over here? Negative 1, 0. Secant is the reciprocal of which one? I flip negative 1, I still have what? Negative 1, very good. So negative 1 times pi is negative pi is my answer. Alright, I'm going to come back to 23 and 24 in a minute. I want to go ahead and look at number 25. Let's look at 25. The limit as x approaches 0. For some reason, these give students trouble, so pay attention to this one. As x approaches 0, I'll plug it, direct substitute. 0 is in the denominator, isn't it? There's the problem right there. So you need to find a toolkit strategy. I see fractions. I'm going to find a common denominator. So I come over here to the side. I have 3 plus x and 3. Can I make 3 become 3 plus x? Can I make 3 plus x become 3? So I settle for both of them. That's my common denominator. If I multiply the denominator here by 3, I got to multiply the numerator. 1 times 3 is 3. So I got 3 right here. Multiply this by 3 plus x, multiply the numerator. You said, Mr. What did you do all here? Okay, I put it under one denominator, and watch what I did. The 3 comes down. Is that a positive or negative? That's a negative 1 times 3. That's why I got negative 3 here. That's a negative 1 times x. That's a negative x. That's how I got that step right there. Now, the 3's cancel out. I'm left with negative x over this. So I take this, and I input it in my numerator. So that was my numerator. I have x. Well, that's a complex fraction. You have a fraction within a fraction that's known as a complex fraction. So I come under and write what it really means. This divided by x. Change it to multiplication. I'm going to flip it. Well, I have a negative x and an x. Can I cancel those out? Yes, but that leaves a negative 1 there. That negative 1 is in front of the x. The x's cancel out, but that leaves that negative 1. So negative 1 times 1 is negative 1 over this entire thing here. Now, I'm going to try to apply direct substitution one last time to see if I get a number. Plug in 0. 3 plus 0 is 3. 3 times 3 is 9. Praise the Lord. So that's why my answer is negative 1, 9. Yes, Mary Kay?
Is there ever a situation where there's no different solution, like that you always get 0?
That's in the next few lessons. Yes. This is still the easy problems. Alright. Number 26. I plug in negative 3. I get 0 in the denominator. So we got to use another toolkit strategy. We're going to either factor or rationalize or find a common denominator. What is screaming to you right now? Factoring. I'm going to factor. I'm going to factor the denominator, get x plus 3 times x plus 2. I can cancel those out and leave 1 over this. When I try direct substitution, that gives me 1 over negative 1, which is negative 1. Number 27, I mean. You said, Mr. Is all this on our quiz tomorrow? Yep. You better know how to solve every one of these type problems. Number 27. Now do you wonder why we reviewed this in math workshop? It's coming up. I'm going to apply direct substitution 4. 2 times 4 is 8 plus 1 is 9. Do I have any kind of 0 in the denominator situation? No. So you're good here. So 9 to the 3 halves. Am I taking the cube root or the square root? Square root. Roots live under ground. Square root of 9 is 3. 3 cubed is 27. That's how I got that. Alright, let's look at number 23. The limit, I didn't mean to put that little to the left, so let's just mark that out and put to the 4. Miss Chester, what you talking about? This don't need to be there. Okay. Alright. I take 4 and I plug it in. What goes on when I plug that 4 in? 0 denominator. Ding, 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 ding. Okay. So I need to use a toolkit strategy. Max, which one would you do? Rationalize the what? Numerator. Rationalize the numerator. So I'm going to come over here. Remember, change that sign. So watch it. Square root of x times square root of x is what, Matthew? X, thank you. Square root of x times 2 is what, Killensworth?
2 square root of x.
Very good. Scotty, what is this?
Negative 2 square root of x.
Very good. Caitlin, what is this? Thank you. All right. Lane, what is this?
X square root of x.
Very good. Constance, what is this? Yep. Good job. What is this right here, Shay?
Negative 4 square root of x.
Very good. Ms. Naylor, what is this right here? Very good. Now let's clean it up. These two cancel out, so I'm left with x minus 4. Now look here, I'm going to apply direct substitution, see what's going on at the bottom. I plug 4 in. Square root of 4 is 2. 2 times 4 is 8, so I got an 8. 2 times 4 is 8. Square root of 4 is 2. 2 times negative 4 is negative 8. That cancels that out, and a negative, so I still got 0 in the denominator. So I look here, I'm going to try to get these two things together so I can factor out the square root of x. I'm going to use factoring. So I'm left with x minus 4 over x minus 4 and square root of x plus 2. These cancel out, leaving me 1 over square root of x plus 2. One last shot. Plug 4 in. Square root of 4 is 2. 2 plus 2 is 4. That is good. So my limit is 1/4. As this function, this monstrous function approaches 4 from the left and the right, it's approaching the value of 1/4. Yes.
In the first step, the very top step, how did you get a for the first one? Like x. So the square.
This step, first, second, third, fourth.
First one.
Right here. How I get 8?
No, it's the very top. Like when, like the x.
This,
No.
this,
No.
this.
Yeah.
X times square root of x is x squared root of x. One's not on the radical, one is. It just goes on that side. Are there any other questions? Yes. Yes.
I'm sorry, I didn't catch on number 25. Where did the negative come from?
The negative 1 right here. Because when you cancel out these x, this x was negative, so that negative 1 times 1 stayed there.
Yeah. Where did you factor out again on number 23? What did you factor?
I factored out the square root of x here, buddy.
Okay.
Yeah.
Yeah, I see it.
Alright, I'm going to give you 5 minutes to do this checkpoint. And then we'll go on to the next one. You cannot use your neighbor, you can use your notes, and that's it. Just give 1 x minus 4. Not have to.
You would.
Because you can learn to use or something, put it back in there. One time, you see what I'm saying? That's what you kept it. You didn't say you put the times. Does that make sense what I'm saying? Are you sure? Because you got x minus 4 and what was the other? Let me bring that to you just a minute. I'll catch you guys sometime. Josh, can you come help me for this, please? Josh, I'm going to give you this. On the bottom here. bust them up, but at the end, you have to come back and write it one time. Remember that? Write what's on the outside one. Does that make sense? Thank you. First read. That'd be what? Rationalize. Josh, come here, bud. When you get done with your checkpoint, you can either go to me or Josh and get it checked. Good job. You have 4 more minutes remaining on this checkpoint. Easy.
For number 3, can I do that, or do I have to?
Have to do what?
Because for that, I didn't pull it out. I just did on top, so I just picked that, so I could cross it out sooner. But do I need to?
You need to show me the mathematics. Okay, but that's all right.
There's a plus by it, or you can approach it
On the right.
right.
Good job. Sorry about your head. Good job.
I get 2, 1, 4, and I get 2. This part, do
Okay.
I?
You multiply this by 2. And then you multiply this by 8, so you need to multiply that part.
It's what I did right there.
But you can't combine any number in a variable. Yeah. See what you can do when you apply yourself? Okay, what's your common denominator? You can make x become 2. We had this conversation, what's your common denominator?
2x.
So if you multiply this by 2, you're going to multiply what? Good job. It's next to what? This one. Back and this is awesome. Okay, you just, okay, that's right. Now what you gonna plug in for it? Oh, okay. Right now. You got the hardest one on page, right? This one shouldn't. You need to find a common one. That's all right. Good job. Sure, I'm good. Did you raise the wolf in this? No, man. That's all right. Here you go. Now, when you can't say these, here's the total opposite. If I tell you how to put there for total opposites. So that makes it what? Very good. Good job. Okay. Q factor this will be x minus 2 and x what? And then, okay, I'm going to show more steps so that's what you messing up again. Something you did right there. Too much in your head right there. Perfect. You need to move what before something. What do you need to factor? You need to put that kind of close to what? That needs to be moved over where? And then factor. Go do that first.
Do you really make a project history? Yes.
2 minutes. This is turned in. It's either right or wrong at that point. You have plenty of time. Good job.
I don't know why this is like not happening right now.
I want you. What's your comment on that? Now, how did you get that to look like that? So you multiply the what? How did you get that to look like that? You multiply it by? So it's not there. Let's do that. When you cancel these, bud, these don't look exactly the same. That's an x minus 2. You got 2 minus x. So that's going to affect it somehow. Now, what you going to factor out? Yep. Good job. What's my common denominator here, Matthew? Yes, I'm going to put 2x right here. How did I get from here to here and multiply lower? Okay, here to here, how did I get there? So if I multiply the denominator by 2, I'm going to multiply the what by 2. So that's going to be what? From here to here, I got to what? Multiply by what? So x times 1 is? So you got 2 minus x over 2x. You see that? Now take that and then divide it by x minus 2. Right at you.
I think I see where I got that before. So,
you're much better than that, son. Now you did all this right. Did it too. Okay, you need to go back to this step right here. If you're done right now, you can work on your homework till I start teaching. But you need to get that. What are you going to take out of this stuff right here? Thank you, bud.
the X.
What they have in common, right?
Oh, it's for it.
What they have in common here?
Two.
Let me go work on that problem, and then work the next one. All right, when you cancel these out, they don't look exactly the same. They're total opposite. What you got to leave there? I'm going to put a negative one right here. So that's negative one right now. You're going to plug one number in. I don't know how you got this right here. That's what the plug's going to do right there.
Oh,
You see what you did?
that one's
See, it's supposed to be negative 1 over 2x, but how did you, this makes sense, but going here to here, I don't understand what you did.
I divided it by 2.
Why are you dividing by 2? That's what I'm wondering. Because at this point, you're left with negative 1 over 2x. You need to try the red. Oh, so good job, Ashley. You gotta go figure it out, but perseverance. Perseverance. Okay, no. You got this right, but you gotta write it final. Like, you're not done out here yet. You're not ready to write this out. You gotta take a word out of this. So, well, you need to come under it. You know how to bust them up. You have those two stages where you have this number, you bring down what's in both the parentheses and what's on the outside. That's what you need to do before you cancel out. Okay? I'm proud of you. Very good. Good job. Proud of you, Chris. Proud of you. All right, I'm about to start teaching. Yeah, you're going to come back. Turn them in. If you don't have 100, 0 period tomorrow. No excuse or call them parent. 0 period tomorrow. 0 period tomorrow. If you're not here, I'm calling parents with you in 0 period. 0 period on time. Not on time, you get what you get on that thing. 0 period tomorrow. I'm going to start. Good job. That's 100. Good. I'm not playing. Don't be here at 0 period tomorrow. See what phone call I make. And don't come up with I overslept. Set 2 alarms. All right. Let's look at page 5. We're going to look at one-sided graphs today. We already kind of did this. Okay, I'm going to apologize for the quality of this picture. So just look up here to see the picture. I redrew the picture with tick marks in it. And guys, we have already talked about one-sided. This should be a little review. I'm not getting into the new stuff today because we need to spend time on the other stuff. But I'm telling you now, for all those videos I post, and you need to go home and watch the videos. If you can't find a common denominator, you need to go watch examples of common denominators. Now, looking at this picture here. The limit as x approaches -6 from the what side? Left side. So I find -6. 1, 2, 3, 4, 5, 6. From the left side, what y value is it approaching? -1. That's your answer. From the right side, what value is it approaching? 2, 3, what? 4. So I got from the left side -1, from the right side 4. Now what if in this case, I didn't ask you this on this paper, but what if I asked you for the overall limit? Because those two values, it's approaching 2 different values, isn't it? Now the third question wants to know, what is f of -6? Would you go with the closed dot or the open dot? Closed dot. I want you to try page 13 tonight. We didn't get far, but I'm going to really hit this hard tomorrow. If you don't know how to rationalize or common denominator, you need to watch some videos. Once again, I repeat, if you did not finish that checkpoint, no ifs, ands, buts about it, 0 period tomorrow. If you have anything to make up, tomorrow. We have got to get our minds back on school and not daydreaming. I'll have that the same. See you later. Have a good day. You too.
Mr. Hester, on Friday, we took that test, and we didn't do like one of the things where you read off the question we had to give.
Yeah, you started it.
Okay.
But I'm on the week is good.
Okay.
our checkpoint today, all that.
You think they got my point?
Yes. All that's gonna be on their quiz mark, just like more problems.
I'm just saying, I don't know how to feel about that.
Wait, how many people failed?
You are one of the 6 A's I had in here.
I've never been good at like graphs and stuff. Like I've always.
That was the hardest test,
With graphs.
hardest unit.
Like any kind of graphs and stuff.
What we just did was?
I've always struggled.
The first one, I didn't do that.
No, I get an 80 out of 8.
This ain't last all that was still on the test.
Yeah.
Wait, the grade 4 last year.
Oh yeah.